Have you ever wondered how chemists determine the concentration of a metal ion in a solution? One of the methods they use is complexometric titration. This process involves a titrant, an analyte, and an indicator to measure precise quantities of metal ions. A classic example is the determination of zinc sulfate in Zinc Care registered trademark eye drops. Through this titration, chemists can accurately gauge the amount of zinc in the solution. Ready to learn how this fascinating procedure works? Then stay tuned. Now, imagine this. You have a diluted sample solution of Zinc Care registered trademark eye drops. Your goal is to determine the concentration of zinc ions in it. You start by transferring 10 milliliters of the sample into a clean conical flask. Then you add 2 milliliters of ammonia buffer to stabilize the pH at 10. Next, sprinkle in a few specks of EBT indicator. This gives the solution a dark wine red color as the EBT forms a complex with the zinc ions. Now the magic begins. You gradually start to introduce about 0.01 m EDTA to the mix. As you add the EDTA drop by drop, it begins to react with the free zinc ions. The EDTA has a higher affinity for zinc than the EBT, so it displaces the EBT in the zinc-EBT complex, forming a more stable zinc-ETA complex. As this reaction progresses, the color of the solution starts to transform. It's a gradual change from a dark wine red to a mixed hue of wine red and blue. You continue to add ETA, drop by careful drop, stirring vigorously after each addition. Finally, when all the zinc ions have been replaced by ETA, the EBT indicator becomes totally free, and the solution turns a pure, unambiguous blue. That's your endpoint. And voila, you have successfully performed a complexometric titration. But what have you learned from this experiment? Complexometric titration might seem complex, but once you grasp the steps, it becomes a straightforward process. Let's recap what we've learned. You start with a diluted sample solution of Zinc Care registered trademark eye drop in a clean conical flask, making sure to adjust the pH to 10 using an ammonium buffer. The dark wine red color of the solution, courtesy of the EBT indicator, signifies the presence of zinc ions. As you titrate with standard EDTA, the color begins to shift. This color change is your roadmap. When you see a mix of red and blue, it's an indication that you're close to the endpoint. But don't stop there. Continue to titrate until the solution turns pure blue. A clear sign that all zinc ions have been replaced by EDTA and the EBT indicator ions are now free. So the next time you come across a complexometric titration, remember, it's all about the color change. Happy experimenting!